Biotelemetry devices are animal-born machines used by humans for acquiring biological data from animals. As wearers, animals are directly affected by having to carry monitoring systems. The interaction between the device and the animal's body determines the device's wearability. The physical and sensory perception that animals may have when wearing tags is at the base of device-induced effects. These alterations impinge on the animal welfare and consequently on the validity of recorded data. Designing wearable devices consistent with the needs of wearer interactors could help in reducing such effects. This research proposes the application of UCD for the development of animal wearables, approaching the issue under the wearer's point of view. A preliminary study was conducted on an individual to evaluate the wearability of trackers commercially available for cats. Two different devices were tested, a small activity monitor and a GPS tracker. The aim was to observe the cat's reaction to different device sizes, weights, and shapes, looking for signs of annoyance. Three conditions were tested: without wearing anything, wearing the activity monitor, and wearing the GPS. Behaviors indicating annoyance were tested. These were grooming, scratching, biting the device, and head shaking. Behaviors were recorded for 20 minutes each hour for 8 hours per day. Reactions of the cat were recorded. This example shows how wearing the GPS led to problems such as discomfort, obtrusiveness, and possibility of falling from the stool. The cat tried to bite and take off the device for a total of 15 times during the 8-hourly repetitions. Findings show how the GPS gets in the way of the cat with increased frequency in comparison with the control and the small activity monitor. Findings highlight the need to rethink the design of such devices in accordance with the characteristics and requirements of animal wearers. In order to do so, we propose a wearer-centered framework which can inform the design of biotelemetry devices. Our framework is in its early stage structure. At the moment, it is composed by a set of 4 interconnected elements. Design principles guide the developer towards the set of biological variables relevant to the interactors. The variables are derived from the wearer's characteristics, activities, and environments. They inform the requirements of the wearers. Wearer, user, and system requirements constrain the design and define the trade-offs between what is ideal and what is actually feasible.